Hello the internet and welcome back to Tony's Tinkering Shop. This is part 2 of the Commodore 64 repair video. If you haven't watched part 1, I recommend you did that. The link is in the description. In part 1, I showed you Commodore 64 I purchased locally, which appeared to work at the beginning, but very soon showed a very interesting fault. I troubleshot the Commodore, blaming a stack bit on the data line, or I don't know, maybe the character ROM itself. In the end, I realized that a stack bit on the data line would likely result in a boot failure, and an issue with the character ROM data outputs would probably result in graphic corruption on the characters, and not the wrong characters displayed on screen. I've also rejected the idea that the character ROM may be faulty inside and somehow display the incorrect characters. This is because custom characters also seem to be displayed incorrectly. Jupiter Landing, which is a graphic game, also was all over the place, so that cannot be caused by the character ROM itself. In the past episode, I replaced 2 memory modules based on these likely incorrect assumptions, but the issue was not fixed. So, at this stage, I feel we need to understand things a bit better, and the next question is, how are characters addressed on the character ROM itself? Now, the character ROM is a 4 kilobytes ROM chip, and I understand it is split into two 2 kilobyte sets. If I'm not mistaken, only one set of the characters can be selected and displayed at the same time. So we can actually consider the character ROM as a 2 kilobyte ROM when it comes to addressing it. Now, 2 kilobytes, or 2048 bits, is a number that can be represented by a 12-bit binary number. If we take a look at the character ROM pinout, you can see that the ROM itself has 12 pins from 0 to 11, which correspond to the 12-bit address the character ROM needs in order to be able to select the whole range of characters it stores internally. Now, I have been researching a bit on this subject because I like to understand how things work. And let me take the opportunity to thank the users of lemon64.com forum, which helped me understanding the basics of character display on a Commodore 64. Really, thank you so much, guys. Your help has been absolutely invaluable. So my understanding is that characters on a C64 are addressed by the VIC chip via an internal table or routine using screen codes. So looking at this screen codes table, you can see that each one of the character on the right, from the @ symbol to the down to the alphabet, is linked to a character code. So for example, the letter A is linked to character screen code number 1, and the letter B is linked to screen code number 2, and so on. Now, each character in the character ROM is basically an 8x8 bitmap, which represents the pixels the VIC chip needs to display on screen. To display a character, the system needs to address exactly the beginning of this 8x8 bitmap. The ROM will then output 8 bits for 8 times, which is our 8x8 bitmaps. If you look here at the picture, this is the letter A. As you can see, you have 8 rows by 8-bit each. So this is our 8x8 little bitmap. And obviously 0 is no pixel and 1 is lighter pixel on screen. And here is how the system is basically generating the letter A. It's basically requesting to the character ROM the content of the memory position corresponding to letter A, and the character ROM will output the actual bits that basically translate on pixels directly on pixels on screen. Now, apologies if I'm now butchering this diagram. Sorry, coding64.org. But basically, the next line in memory, so over when the system reaches the end of this 8x8 little bitmap, the following line is going to belong to a different character. Very much oversimplifying things. If the first line for my character here is line 0, the next character will start at line 8. Again, please ignore that this is A and then it's A again. I just didn't want to spend too much time making drawings, but I hope you understand what that means. So using screen codes, And let's assuming that this is the screen code 0 is for the letter A for a second. You multiply by 8, you get 0, which is the first line of character A. The VIC chip will then cycle through all the memory locations to get to the 8th line. And to get to the next character, the memory location is going to be 1 multiplied by 8, which is line number 8, or the 9th, if you want to consider 0 as line number 1. And that will belong to the next character on screen. So that's how screen codes work on a C64. You basically multiply by 8, and that will give you the memory location of that character, the beginning of that little 8 by 8 bitmap, which is then used to display pixels on screen. Based on these new assumptions, let's try and revisit for a second the fault that this Commodore 64 has, which is the incorrect characters on screen. Now, previously I addressed that using data lines and assuming there was a stuck bit on the data lines, but again, we discovered, or at least we now assume that a data line may not be involved because of what I just said. So let's revisit everything, imagining that we may have an issue with addressing the characters rather than displaying the characters. Now, let's go back to our good characters on screen, which are C, D, R, and E. You have here the screen code for each character. You multiply that by 8, which is to get to the beginning of the memory location which belongs to that character, and this is basically the address in binary that the character ROM needs to receive, needs to be presented to, in order for the memory to start displaying the correct character on screen, or to basically supply the VIC the correct pixels to be displayed on screen. Now, if I'm looking at the characters which get changed, so O becomes a G and M becomes an E, that's the math and everything. So this is what the address should be, and this is what the address happens to be. And you may notice that, again, on both of these characters, you have a stuck bit, which is, it's stuck to 0. It's a bit which is supposed to be 1, but actually 0. And if you check on the good characters, you notice that that bit happens to be 0, so that's why the displayed correctly. So again, it's the same logic that we did together with assuming that it was a data line issue, but this time looking at address lines rather than data lines for the reason I mentioned. And again, if I'm not mistaken, if I'm looking at these 12 bits, this is supposed to be address line number 6. Now, you may remember that when I was probing the address lines on the memory modules, I was reading something weird on exactly address line number 6. I also noticed that the address line 6 on the character ROM, when the character ROM was being selected, was always getting a low value. Now, unfortunately, I lost the footage for that, so you'll have to trust me. But basically, address line 6, which is pin number 2, I could clearly see on the oscilloscope that when the character ROM was being selected, the value was always low. So if I'm following address line 6 on the schematics, at least on this part of the bus, on the address bus, I see it goes through a latch chip, which is the U26 or LS74373. We checked that chip last time, even though somehow I mixed out address line and data lines, and it seemed to be fine, but we noticed that address line 6 was always low. So I think it's time to continue our investigation and see what's beyond U26. Now, among other things, I see that following address line 6, I end up in U14, which is a 74LS258. And I think I would like to take a look at that. The 74LS258 is a multiplexer. Again, I'm not an expert when it comes to electronics, but if I'm looking at the function table or the connection diagrams here, basically it's one, two, three. It's a 4 sets of multiplexers, I guess. But we basically have 2 inputs, 1 output, and what kind of output you get depends on two pins. One is the output control, where the output control basically, if it's high, the whole chip is disabled and all the outputs are high impedance or switched off if you want, but they're not low, they just don't interfere with the bus. Whenever the output control is low, then it depends what the select line is doing. If the select line is low as well, the chip outputs the input on the port number A. If the select line is high, then the chip outputs the input on input port number B. Well, number B doesn't make any sense. On port B. The 258 in this case actually outputs the inverted signal. So, say for example, first line, if my select line is low and my port A is low as well, my output is going to be high. So it's the opposite of port A. If my select line is high, then the chip is passing port B, but inverted at the same time. So the bottom line is whenever my select line, whenever my output control is low, then I'll check what the select line is doing, what's on port A and B, and there should be a matching or opposite, well in this case the 258, so it's going to be an opposite output at the output. Now the problem is I don't have a 5-channel oscilloscope, so I can't check output control, select, A, B and output at the same time. So I'm just going to check, I need to know output control and select what they're doing, and obviously I want to see the output, so I will check an input at a time. So let's move on and check output pin number 4, which is going on my D6 on the 74LS353U26. Pin number 4 is on the schematics output Y1, which is connected to inputs A1 and B1, pin 2 and 3. So let's check input A1 for the time being and see what I get out of it. I've labeled the signals. So again, we basically said output control must be low. So ignore everything which is output control high. And again, let's see what happens. We are checking port A. When select is high, it's going to pass the other port. So we don't care about when it's high. But when it's low, and this is low as well. So for example, here, it should be the invert of the input. Now input is high and my output is low. So to recap, output control is low, so the chip is active. Select is telling me, because it's low, it's telling me I'm passing port A. Port A is high and output is the opposite, is the inverted, which is low. Totally fine. So let's check here again. This must be low. This means port A is high and output is low. So totally fine. Let's check again. Take another reading, and again I got low, and again input high, output low. Totally fine. Low, input high, output low, and this is the same. I don't know. Here we go. Low, input high, output low. So this seems to be working fine. Just one thing, the input is always high. And if I run this thing, you can see that input is actually always high, regardless what happens. Let me try and reboot the 64, see if it ever gets any different. Nope, it's always high. So that's a little, again, it seems to be working, but it's just that line is stuck high, which is a bit, I don't know, I'll keep that in mind. So the next step would be to check what happens on the other port B, because again, A1 is always high, but I want to also see when select is high, which is port B inverted. So I need to move a probe and check what port B is doing. And there I moved my input probe to port B, which is pin number 3, and if I power it up, you can't see the screen, but the 664 is not booting up anymore. And if I take a reading, more than one, I see something strange of that input port. Let me change the horizontal scale here, and you see this thing, which doesn't really make much sense to me. It's doing this weird shape, And most importantly, the 64 doesn't power up. So it turns out that whenever I have a probe connected to this pin, the 64 doesn't power up. And looking at the schematics, I can see the pin number 3, which is input B related to the output and monitoring, is actually looped back to output pin number 12, which is Y2, which is another output. So it's basically getting the same output and taking it back again inside, looping it internally again. I don't know what's the reason. I don't know whether there's a good electronic reason for my oscilloscope probe to upset the whole 64 when this happens. I have absolutely no idea. Feels to be weird. I appreciate the oscilloscope is introducing some impedance, but I wouldn't expect, especially on a 1983 device, I wouldn't expect something to be upset by a modern oscilloscope's probe, to be honest. So, because I don't know about this, I think the only way to check whether there's something wrong with this chip or not is to check a working C64 and see whether it shows the same behavior. And this is my working C64. I went ahead and socketed these two chips. This one is the one I'm working on. Let's see how it looks on this one. Again, we are monitoring input pin number 3, which again is looped. It's coming from the output pin number 12, Y2. And let's see how it looks on this one. It looks so much better. Again, it's doing something. I don't know, again, it doesn't show that weird thing, and most importantly, the C64 is booting up as it should, and there's actually a cursor blinking. Wow, I haven't seen it for a while. So I definitely have a problem with that. And to be honest, if I'm looking at the schematics, that line is just, it's output going into an input. It doesn't go anywhere else. So I would definitely think that chip has a problem. And by the way, it happens to be a MOS chip, which I understand, they're not very reliable. So let me do some few more tests on this chip before I go ahead and replace the whole thing. Now, before I put away this working C64, let me check pin number 12, which is linked to pin number 3 anyways, which is getting out inputs from pin 13 and 14, A2 and B2, which are linked together. So it doesn't really matter where the select line is high or low, the input is going to be exactly the same. Let me show you what I see on the oscilloscope. Okay, again, the C64 is up and running, and basically, in this case, output control must be low for the chip to work altogether. Select line, basically, it doesn't matter because the inputs are joined together. So I can check whether it's high or low, and I should have the opposite between the input and the output. And as you can see, low becomes high, high becomes low, and whenever I'm checking, the waveforms are always opposite, which is exactly what it's doing again. So this is coming from low to high, and this is from high to low. And it seems to be working totally fine. So I don't see an anomaly here, but again, the other C64 is even refusing to start, and it has that weird waveform on a line which is basically looped inside the same chip. So there's nothing around that can affect that one, to be honest. So I feel there's something wrong with this chip, and so I want to replace it and see if this time I got the right one. Okay, new socket is there. The chip is from the other Commodore 64. I haven't got a spare for this one. And now I haven't connected the video output, and I haven't tested it off camera. First thing, I would just want to power it up and see what I read on the line which was reading that wonky waveform. So I'm just curious to see what happens before I power it up. And yeah, something's happening. It's not wonky anymore. There we go. And yeah, there's definitely something happening. So who knows? Maybe I fixed it, maybe not. There we go. Final test. Well, final. Let's test it. And again, this is first time on camera, so let's see what happens. 3, 2, 1, go. Yes, it works. Whoa, that was amazing. Fantastic. So it's a faulty MOS chip, as apparently happens very often, right? You may notice that this is not the only fault on this machine, though. So the fan is not over. because there's no keyboard. There's no keyboard, unless I need a keyboard connected for that to happen. That's a chance. I don't think so, but let's give it a go. Right, I've got a known good keyboard connected to it. Let's see what happens. And no, there's no keyboard. So fault number 1 seems to be resolved. Now we have fault number 2, which, to be honest, should be fairly easy. It should be a CIA, right? Or maybe some connections. But yeah, I guess that's a much less interesting fault. Keyboard's not showing up. Now, before I dive into the keyboard issue, let's power up with the that test cartridge and see whether everything checks out. Yeah, everything seems to be working. Wow, that's amazing. And yes, we do have an issue with the CIA. You can see these timers. This is working properly. 36 seconds is roughly the time has passed since the last time it was updated. And this is reading, what is this, 1 hour? Yes. And if I'm not mistaken, AM is the left-hand side, which is the one connected to the keyboard. And the keyboard happens not to be working. So that's probably another little clue that the CIA, unfortunately, is gone. And everything checks out but the CIA. Well, let me try Jupyter Lander first and make sure that graphic modes works fine. Here we go. Oh, it's so nice to see this. I've been studying schematics for a few days, so this is quite nice to see. Yeah, graphic mode, everything works. Character work. Yeah, everything works fine. But yeah, to be honest, do I need any further diagnostic like with the oscilloscope on the SID, on the CIA? I mean, the software is telling me it's bad, the keyboard is not working. I can redo the soldering first, maybe, just in case, but I guess I'll need to socket it and just swap it. Now, regarding the keyboard problem, again, the that test cartridge showing the timer on the CIA number 1 is not working. And from my probably incorrect understanding, if the timer is not working, the CIA is not scanning for keys. And I guess it's also responsible for blinking a cursor on screen. So I happen to have one which is probably partially working. It's from another 664. I think the keyboard works, but the serial port doesn't. So it works on slot on how's it called, on U1, but it doesn't work in U2 when you connect a floppy. I guess U1 is doing the keyboard and the user port, something. So probably if you connect a cassette with this, it doesn't work. But I remember it worked with a keyboard. So let's try it out. If that works. Otherwise, I'll get the other one from the working C64. Let's power it up and see what happens. And there is a cursor, blinking cursor. Let me plug a keyboard. There we go. Welcome back. And here we have working C64. Again, this CIA doesn't really work fully, but for now it's okay. For testing, I will have to place an order for another one. The SID hasn't been tested yet, and that's definitely something we can try in a minute. Yes, timers are working. Well, and there is sound. So, final test for this video. Let's see if I can still play Bubble Bubble, which I think is the only software I actually have on an SD card. Right, this is it. I hope you enjoyed the video. Thank you for watching, and I hope... Wait, there's a little extra. Now, totally for fun, I was probing this old chip, which I put back on the board. And at some point, I realized that if I'm probing pin number, I think it's number 2 or number 12, while the video is running, this is what happens. Probing, not probing. Probing, not probing. It turns out that this specific probe is fixing the problem. So I decided to understand what was happening. So it turns out this is kind of a defective probe. I can't remember how I damaged it, but it only works on 1x scale, if you want to call it that way. I thought it was working. I think I noticed the other day that when I was probing some of the chips here, it was causing the C64 to crash. So I thought, okay, that the probe is shorting or doing something, I'll just throw it away. But again, tonight I decided to understand why that's happening. And I basically found that the probe is basically showing about 1 kilo ohm between ground and the probing tip. Basically, when I'm probing with this probe, I'm basically adding a 1 kilo ohm resistance to ground to the probe pin. So I guess maybe am I pulling down the line? So I decided to do a test with a 1 kilo ohm resistor. So here's a little test lead. I have one end connected to ground and one end connected to 0.8 kilo ohms, and what I'm doing, I'm basically touching pin number 12 and to see what happens on screen. And look what happens. So I'm not touching now, and I'm touching now. But look at that. So if I add the resistor on the affected lead of the bad chip, it goes back to normal. It works. I fixed the chip. Not only did I fix the C64, I also fixed the chip. Now let's check on the oscilloscope. So this is me probing pin number 12. The video is corrupted, but the moment I'm adding a 1 kilo ohm resistor to the same pin, there you go. The video is back and the line is healthy. Look. I think it shows some kind of weird, it's not exactly. It shows this weird waveform, which I feel it's still incorrect, but somehow the rest of the system is happy with it. Again, you can see it's not really a square wave, but the video is fine. Look at that. It works, and yeah, I guess I don't need the new chip anymore. I'm just joking, but it's quite interesting. I hope you enjoyed the video, and I hope to see you back soon. Thank you very much, and have a great day.